Welcome back. We have a collision problem here and it reads two bodies A and B with masses 60 kilograms and 40 kilograms moving at 80 meters per second and 60 meters per second respectively had a head-on collision such that after the collision A continues to move in the same direction at 50 meters per second. Calculate the velocity with which B moves after collision. Is the collision elastic or inelastic? So what we have understood from this question is it is asking us to find the final velocity of B after the collision and also to determine if the collision is elastic or inelastic. Trying to collect the data from the question here, we know that the mass of A is 60 kilograms. The mass of B is 40 kilograms. The initial velocity of A is 80 meters per second. The initial velocity of B is 60 meters per second. The final velocity of A is 50 meters per second. The final velocity of B is what we are going to find. Another important thing mentioned in the question is that there was a head-on collision. A head-on collision means that the two bodies were moving in opposite directions before they collided. If I have body A, let's say, is moving in this direction towards the right of mass 60 kilograms and an initial velocity of 80 meters per second, for there to be a head-on collision with body B, then body B has to move in the opposite direction. Okay, its mass is 40 kilograms and its initial velocity is 60 meters per second. So which means that the body B is going to move towards the left. Okay, this is the situation before collision. But after collision, A has maintained its direction, okay, because that is mentioned in the question. The final velocity is 50 meters per second. But we don't actually know the direction of B, that is the 40 kilogram mass. What is clear is its initial direction is towards the left, so it means it is going to have a negative velocity. But we don't know its direction after the collision. We're going to calculate that. That is VB. If we have a negative value for VB, it means it has maintained its initial direction because its initial direction is towards the left. So if you have a negative answer, it means that it has still maintained its direction and it is moving in the negative direction. But if at all we have a positive value, which means it has reversed its direction. Okay, so that is how you deal with momentum problems. If at all the initial velocity is in the positive direction, if the final velocity is negative, it means it has reversed. But for a body that is initially having a negative velocity, it is only when you have a positive velocity, it means that it has reversed its direction. This is the situation after collision. What we can do is to apply the principle of conservation of linear momentum, which states that the total momentum before collision is equal to the total momentum after collision. So that will be the mass of A multiplied by the initial velocity of A plus the mass of B multiplied by the initial velocity of B. This must be equal to the mass of A multiplied by the final velocity of A plus the mass of B multiplied by the final velocity of B. So the direction for body A, because it's moving towards the right, is positive, and final also is going to be positive because it has maintained its direction. So we're going to use these sign notations. They are very important. So what is the mass of A is 60. That will be 60 multiplied by the initial velocity is 80 plus the mass of B is 40 multiplied by the initial velocity is going to be negative 60 for the fact that it is moving towards the opposite direction, that is towards the left. The mass of A is 60 multiplied by the final velocity of A is 50 plus the mass of B is 40 multiplied by VB. That's the final velocity of B. So 60 multiplied by 80 gives 4,800 plus 40 multiplied by negative 60 will give negative 2,400. This is equal to 60 multiplied by 50 is 3,000 plus 40 multiplied by VB is 40 VB. So I will have 4,800. Positive negative will be negative. 2,400 is equals to 3,000 plus 40 VB. 4,800 minus 2,400 is 2,400. This is equal to 3,000 plus 40 VB. So 2,400 minus 3,000 is equals to 40 VB. That is going to be 2,400 minus 3,000. Negative 600 is equals to 40 VB. If I want to find VB, I will divide both sides by 40, both sides by 40. So VB is equals to negative 15 meters per second. So which means VB is moving towards the left. So we can say, we can indicate our arrow like this. That is, the final velocity of B is 15 meters per second. So it means that B has also maintained its direction because it was moving initially towards the left. We got a negative value for V, so which means it is also maintaining its direction after the collision. The final velocity for body B is 15 meters per second, and it has maintained its direction after collision. This question is answered. All right. Now, this is the trick I want to give you. If at all the initial velocity was in the positive direction, if you have a negative velocity in the final, it means it has reversed. But if the initial velocity is positive, the final velocity is positive, it means it has maintained its direction. If the initial velocity was negative, the final velocity is negative, it means it has also maintained its direction. Okay, but let's say the initial was in the negative, the final was positive, it means also that it has reversed its direction. So for this case, its initial velocity was in a negative direction and we got a negative final velocity, so which means it has maintained its direction. Okay, for body B. Moving on, the second question is the collision elastic or inelastic? Well, we can only know this if we determine the total kinetic energy before collision and the total kinetic energy after collision. If the kinetic energy is the same, then you are dealing with elastic collision. For elastic collision, kinetic energy is conserved. For inelastic collision, kinetic energy is not conserved. For inelastic collision, kinetic energy is greater before collision than after collision. Why? Because there is loss in kinetic energy. And the energy is lost into heat, sound, and deformation. Okay, you can also talk about potential energy. For inelastic collision, you will have a kinetic energy that is higher before the collision than after the collision. Okay, so total kinetic energy before collision. The total kinetic energy before collision is half the mass of body A, initial velocity of body A squared, plus half the mass of body B multiplied by the initial velocity of body B squared. So that will be half mass of body A is 60 multiplied by 80 squared plus half multiplied by mass of body B is 40 multiplied by the initial velocity is 60 squared, and that is going to give you half multiplied by 60 multiplied by 80 squared. You're going to have 19,200 as the kinetic energy for body A, plus half 40 multiplied by 60 squared. You have 72,000 as the kinetic energy for body B before collision. If you add these two, you have 264,000 joules. So this is the total kinetic energy before collision. Now we'll find the total kinetic energy after collision. The formula for total kinetic energy after collision is half mass of A, final velocity of A squared, plus half mass of B multiplied by the final velocity of B squared. This is going to be half. The mass of A is 60 kilograms multiplied by the final velocity is 50, that will be squared, plus half. The mass of B is 40 kilograms multiplied by the final velocity that we calculated was negative 15, then square that. That will be half 60 multiplied by 50 squared is 75,000 plus half 40 multiplied by negative 15 squared, that will be 4,500. If you add them together, you have 79,500 joules. So this was the total kinetic energy after collision. So if you look at it, you have a kinetic energy before collision higher than the kinetic energy after collision. So it means there is a loss of kinetic energy. And whenever you have that, you are dealing with an inelastic collision. Okay? Because there is loss in kinetic energy, the collision is inelastic. The loss in kinetic energy is equals to total kinetic energy after collision minus total kinetic energy before collision. That will be 79,500 minus 264,000, and that will give minus 184,500 joules. The negative sign is an indication of a loss in kinetic energy. So remember, the kinetic energy is lost into heat, sound, it can also be light, and deformation. That is all for today. If you like this video, please subscribe and hit on the notification bell. Thank you very much.